So this week we are going to be doing Study Island, AC Program's 5th grade science, retiring July 2020. Topic 6A about the Earth, Sun, and the Moon. So I just took the notes from Study Island and I actually added a little bit extra just to help with your understanding and to make sure that more information is provided. And also these notes are going to go directly with my practice questions. So I added some extra questions that are not included in Study Island but based similar to them as a way to review and practice before you take your test. And so as you go through the notes, you'll see over here practice questions 1 through 6. Practice questions 1 through 6. So questions 1 through 6, you'll find the answers in this section of the notes. Questions 7 through 10, you'll find in this section of the notes. And I made sure that I took these notes in Cornell style. So I have my questions over here, or my topics and my headers on the left side, and the information that accompanies it in the main section. Alright, so the Earth's rotation and its revolution. The Earth is constantly in motion. The two main types of motion that the Earth is constantly going through are rotation and revolution. And these two words are very easy to confuse. Sometimes even just people talking normal, we easily confuse these two words. But the word rotation means turning or spinning. So if this right here is the Earth, and you imagine a little dotted line going right through the middle, going from the North Pole down through the center of the Earth and out through the South Pole. And there's that little line right there. And let's say you're sitting right here on the Earth on my little metal part of my pen. Every day, the Earth is turning, and it's going to go around and around and around. And you on that metal part of the pen, you're going around and around and around, around, until you come back. And that takes about 24 hours. You do that every single day. And that is called rotation. So the actual object itself is spinning or turning or rotating. Okay, so rotation means turning or spinning. And this is just like we learned 2 weeks ago in our math about rotation, reflection, and translation. So if I have a triangle 1, like this, if I rotate my paper, let's draw the same one. Wait, nah, I'm not going to draw the same picture. It's going left. Okay, yeah, that will be the same. So these two triangles are rotated because I could start with this one, and if I turn it that way, I get the same picture. Rotating, you're just turning, or twisting. The Earth is rotating when it spins on its own axis. It takes 1 day, or 24 hours, for the Earth to make one complete rotation on its axis. So every day we do a rotation. The rotation of the Earth is responsible for night and day. The side of the Earth rotated toward the sun experiences daytime, while the opposite side of the Earth, which is rotated away from the sun, experiences nighttime. So if I come back to my little pen example, then let's take the sun. Here's the sun, bright yellow. So right now, the little metal part, it's kind of facing toward the bright yellow sun. So we're probably getting some daylight right now. As I turn my pen, or turn the Earth, so the sun's over here. It's pointing straight that way. We're maybe getting a little bit of sunlight, but not as much. So we're going to be maybe at sunset now because we are moving away from the sun. As we keep going, now the sun's over here and it's being blocked by the Earth. So we're turning into nighttime, 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 nighttime. Then as we get to the back, we're starting to come back toward the sun again. So now we're going to be at sunrise or dawn. And then as we come out this way, we're now facing the sun again, so we're going to get some daylight. So the sun doesn't change places. The sun is going to stay just right there, just chilling out or heating out. I don't know. But it's just going to be hanging out there, not doing much. As we're spinning like this, and then we're also doing one more thing. We're also revolving. So while we're spinning like this, we're also making a big circle around the sun. So we're kind of doing two motions at once. And so that second motion that I was making, that big circle around my sun, my marker, is revolving. So revolve means to move in a circle around something. When the Earth moves in a circular pattern around the sun, we call it orbits the sun. And that means the Earth is revolving. So the revolution of the Earth around the sun and the tilt of Earth's axis are responsible for the changing seasons. It takes the Earth about 1 year, or 365 1/4 days, to make one complete revolution around the sun. So this is the Earth and this is the moon. The moon is actually revolving around us, and it's also rotating as it comes around us. And as it's going around us, we're going around the sun. So there's so much motion going on, and we feel none of it. But if it stopped, we'd probably really notice. Seasons. The Earth experiences 4 seasons throughout the year: winter, spring, summer, and autumn. Phoenix experiences 1 season throughout the year: summer. Each season, no, we do experience all 4 seasons, but it just feels hot all year. Each season is determined by where the axis of the Earth is pointing. So if the North Pole is pointing toward the sun, the South Pole will be pointing away from the sun. During this time of year, the northern half of the Earth will experience summer, while the southern part of the Earth will experience winter. So if I draw my Earth, draw my axis through it. So this is the North Pole, South Pole. And if I have my sun over here, we'll make it bright yellow. Okay, so it just looks closer. It's not really any closer. But as the sun points at the Earth, it's going to give a lot more sunlight to the North Pole that's pointing toward it than it would to the South Pole. If my sun is over here and the South Pole were pointing at it, then I'd be getting more sunlight pointing at the south. So when we have a lot more sunlight, the sun stays up longer and we get summertime. When we have less sun landing on the Earth, we get winter time and less sunlight hours. So the seasons continued. When the North Pole is pointing away from the sun, the South Pole will be pointing toward the sun. During this time of year, the northern half of the Earth will experience winter, while the southern part of the Earth will experience summer. So, if you were to imagine, so we have the Earth, North Pole, South Pole, axis going through it, and if we imagine a perpendicular line going through the other diameter, this would make my north, and this would make my south. Then up here, when it's wintertime in the north, it's actually summer in the south. So that means if you celebrate Christmas, we normally do it in winter here. But if you were to go visit Australia or Brazil, Madagascar, any country that is south of the equator, it's actually going to be summertime when Santa Claus comes along. So that's kind of cool, I think. The Earth's day and night cycle. This is going to help you with questions 7 through 10. The Earth's rotation on its axis, as it revolves around the sun, is what causes the change from day to night every 24 hours. This model down here shows the relation of the sun to the Earth. So this is my sun right here. Sadly, black and white doesn't really help very much. Okay, so this is my sun. So if I'm at point A right here, I'm going to highlight it. Point A, you can see that if this were a ball, then the side of the ball that's closer to the sun is going to be nice and bright. So A is experiencing a time where it's very bright. A is going to be what? Daytime. And then my other point, I've got one hiding right there and one hiding right there. There we go. I'll put a silver marker. All right, so point B, that's like right in between. It's not on the light side. It's not on the dark side. It's right on the line in between light and dark. What could you think of that being? So there's 2 times every day where it's either not quite nighttime, but not quite daytime. So sun, dark, between. So first thing in the morning when the sun just barely starts to come up, that's called dawn or sunrise. And then at the end of the day, when the sun starts to go down and the sky turns all sorts of colors, then that would be sunset or twilight. So, it's not super bright. You're not going to feel like it's the middle of the day anymore, but it's also not super dark. You still can't see all the stars, or you can't see all the stars yet. So dawn and sunrise, or sunset and twilight, those would happen at these, what's called a margin, the area between. So what we have to do to decide if we're at sunrise or sunset is look at the way this Earth is turning. So this set of arrows is saying that the Earth is turning this way. Okay? So, turning that way. So if point B is right here, and it's turning this way, is it going to become daytime or nighttime? So we're starting out right here, and we're turning this way. It's going to become daytime because it's turning toward the sun. So if you were living at point B, you would be seeing a sunrise. Point B is experiencing sunrise because it is on the boundary of the light and dark sides of the Earth, and the Earth is rotating in such a way that point B will be on the bright side of the Earth next. So as you're answering these questions on the practice and on the test, if it helps, grab a pen or a pencil that has a little hanger, a thing that you would be able to hook it onto something with a hook, I guess, and use that. If you don't have something with a little point, maybe it has words on it. Maybe your pencil says the brand that it is in number 2. Use that as your location, and then turn it the same direction as the arrow. So if you were living at point C, right there, it would be nighttime because C is located on the dark side of the Earth. So remember, we have a big round ball, which is the Earth, and at about the very highest point, everything behind that spot is going to be dark in the shadows. So that's going to make nighttime. So night, and then it turns, we go to sunrise, and then it turns, we go to daytime. If we were to pretend that we could go all the way back here and have a point somewhere here, but it's on the other side, where it's like right on that border of dark and light, we would be coming from the light, from the daytime, into the nighttime, and that would be a sunset. Motion of celestial objects. So as we got from our Unit 20 and 21 from my pals, celestial objects is just a fancy way of saying things that are in outer space. Basically everything out there outside of Earth, except for our own satellites and things that humans create. So celestial objects would be things like the moon, the sun, the stars, asteroids, meteoroids, all those good things, comets. So The motion of the stars and the sun in the Earth's sky is due to the Earth's rotation. So the sun and stars, they're not really moving in a circle around us. They're just kind of there. They may be slowly spreading apart, getting farther away, but for the most part, they'd only be going one direction. They're not doing this. Stars don't do that motion. Oops. Stars don't do that. Nope. So for the most part, we can say that the stars stay in pretty much the same spot. So the motion of the stars and the sun in the Earth's sky is due to the Earth's rotation. It is the Earth's rotation that causes the sun to rise in the east every morning and set in the west every evening. So if we were to imagine that this is a horizon, the sun doesn't go like that every day. The sun doesn't actually move around us. We are actually turning. So instead, it's more like that. And so because we are moving, it looks like the stuff around us is moving. Mind blown. So how about Earth? If you were to take your camera, so grab a cell phone, turn on the camera, and maybe have brother, sister, parent, somebody, some other human being, stand in the middle of the room holding the camera. Have the other person walk around you, rotate around you a couple times, and look at the camera as they're doing that. You see, it kind of looks like they go from here to here, and then when they're out of your view, you can't see them, and then they come back, and it's going to look like they're moving just like that, which they are. But now, tell that person to stand still. So, tell the sun to stay where it is, and instead you spin around. So instead of them moving, you just rotate. Go like this, okay? So as soon as you are pointing right there, you're going to catch them on your camera. And you're going to catch them. You're going to definitely see them catch. And then once you get too far away, you're going to stop seeing them out of the corner of the camera, and they're going to be gone. And if you compare the videos, they'll look very similar. Because in both cases, the sun came up onto the camera and moved past it. But it's because of, I'm talking about rotation. So because the Earth is moving, it's going to look like a sunrise and a sunset. So this rotation also causes stars to move in the night sky, with the exception of the North Star, also called Polaris. The reason this star appears to stay still in the northern night sky is that Earth's axis of rotation points almost directly at the North Star. So there is one star in the sky. So Polaris is always right there because the way that the Earth is pointing, we're kind of pointing at that star. So if we are turning, we're going to always see it in the same spot just about. But any stars that would be out here, as we're spinning overnight, so Polaris is always right there. So this one, at this point, is from my middle to there, to there, to there, and to there, there. Okay. So that's how I see all the stars at the first part of the night. And then if I move a little bit, so my middle piece is right here now. So everything is at a slightly different angle as I move. And let's go with another color. That'll work. And then if I'm over here, so Polaris never moved, but the other ones, they're at a slightly different angle from where I am now, so it looks like they moved. I have a video that I will post that kind of explains that a lot better than I can on just a little paper. Alright, so what causes the phases of the moon? Yeah. Okay. So the half moon, half of the moon is always lit by the sun. Just like the Earth, half of the Earth is always lit by the sun. And it's going to be whichever side is closer to the sun. But because the moon is revolving around the Earth, the amount of the moon that we can see from Earth constantly changes. The changes in how much of the moon we can see from Earth are called the phases of the moon. So this is a diagram of the phases of the moon. And we have the sun right here. Color it in, make it nice and yellow. I like my yellow sun. It's probably more of an orangey color, but I'm making it yellow today because that's what I have. Okay, so I've got my beautiful yellow sun there. And it is shining light. So if this is Earth, we are a nice little lovely green and blue color. Put some green on there, put some blue on there. There we go. Earth. So if you're standing right here on Earth, and you're looking out to the moon, and the moon is right here in the sky, the moon does not make its own light. It reflects light from the sun. So if the moon is standing between you and the sun, is that moon going to look very bright? No, because it's the back side of the moon that's going to be lit up, and the side that's facing you is going to be dark. So you're going to see it something like that. If the moon moves a little bit away, then you can have a ray of sun that goes there to there. So it's going to light up this back side, but the side on the other end is going to still be dark. So if we're standing here on Earth, we're only going to see part of the sun lit up. As it moves a little bit farther, the moon's going to be lit up by the sun on half of it. If we look up from Earth, we're going to see a half moon, first quarter. If we go over here, if the moon is past us, the sun, we're not going to be blocking it, so it's going to be nice and bright. Full moon, the sun is able to send its rays all the way over there. So normally, the Earth is not in a direct line from the sun, the Earth, the moon. The moon might be at a different level. So maybe it's more of a diagonal coming up. It's just we're doing a two-dimensional drawing, so we can't do that. So the moon probably normally is not like this. It's probably more like that. So the light from the sun can still hit the moon and then reflect back onto the Earth. If we do have the sun, the Earth, and the moon all in a perfectly straight line to where the light has to go past the Earth to get to the moon, we have an eclipse. Gibbous is going to be, you get a lot of sun but not all of it. Waning, you get a lot of sun but not all of it. Crescent, a little bit of sun. And the new moon, you can't see it all. So the sun shines on exactly one half of the moon, except during a lunar eclipse. From Earth, we can only see the part of the moon that is lit by the sun. You can't see a dark object in space that doesn't have light on it. Light is what helps us to see. So at nighttime, when it's completely dark inside your house, you can't really see anything. If something has a light shined on it, then you can see it. So when that moon, if it's not sending us light, we can't see it. So from Earth, we can only see the part of the moon that is lit by the sun. As the moon moves around the Earth, the amount of lighted half of the moon that we can see from one point on Earth changes. These changes give us the phases of the moon. the moon makes one complete cycle every 29.5 days. So it takes about 29.5 days to go from a new moon all the way through the crescent moon, the waxing first quarter, the waxing gibbous, the full moon, the waning gibbous, the third quarter, the waning crescent, and back to a new moon. That's about 29.5 days. When we name the moon phases, it is based on how much of the moon we can see from Earth, and whether it appears to be getting larger or smaller. For example, a crescent moon can be either a waxing crescent, which would be that one right there, or a waning crescent, depending on if it will appear larger, waxing, or smaller, waning tomorrow night. New moon, first quarter, full moon, and third quarter are not called waxing or waning. So extra info from me. A lunar eclipse happens during a full moon if the Earth blocks the sun from lighting up the moon at night. It can happen a few times a year, but only certain parts of the world can actually see it. So depending on where you're standing on the Earth, you may or may not be able to see a lunar eclipse when it happens. Okay, and then just the names of our moon phases. So this is a picture of various moon phases taken on different nights. This would be a crescent moon, and you can see each day it was getting bigger, 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 and it turns into a full moon eventually. New moon. The moon is invisible from the Earth. This phase results when the moon is on the same side of the Earth as the sun. During the new moon, the entire lighted surface of the moon is facing away from the Earth. So the lighted side is on the back side of the ball. It's facing away from us. We can't see it because the light can't get to us. The moon is in the way of itself. We call it a new moon because there's no moon right there. And that's the very last point before it starts over where we can see it. So it's going to start a brand new cycle. Crescent moon. A crescent moon looks less than half full, but not completely dark. The quarter moon. A quarter moon is when half of the side of the moon facing Earth is lighted and the other half is dark. So it would be about here. That looks about half and half. There are 2 quarter moon phases in a cycle. A gibbous moon looks more than half full, but not quite full. So, quarter, gibbous, full, gibbous, third quarter. That's also kind of, either one of those would be halves, give or take, crescent, crescent. Full moon, the phase that results when the moon is on the opposite side of the Earth as the sun. During the full moon, the entire lighted surface of the moon is facing the Earth. Therefore, the moon appears brightest on Earth during this phase. Waxing. The moon is waxing stage of its cycle when the size of the visible part is increasing. Waning. The moon is in the waning stage of its cycle when the size of the visible part is decreasing. And that's pretty much all I have for the notes. The review, the practice, just go through the notes. Think about the definitions I gave you. Think about the information. Questions 1 through 6 are asking, is this a rotation or a revolution? So students sitting in the teacher's chair started to spin around. Think of what's happening. So this is the chair and the student. They're making this motion. Is that a rotation or a revolution? So read all 6 of these. Decide rotation or revolution. Question number 7, 8, 9, and 10. All 4 of those questions are asking about this picture right here. So question A, B, C, and then on the back side, it's asking about a point D. So if you were to imagine a point D somewhere on the back side that goes through this white line right here, what time of day would it be? And then the last 2 questions are about movement of celestial bodies and phases of the moon. And that's all you need to do, and that should only take you a couple minutes. This lesson has taken about 30 minutes, so take no more than 30 minutes to finish that review. Thanks, guys, and great luck.